Hello and Assalamualaikum. My name is Izzah Atira binti Ahmad Sirfan. I'm from J4EM 1104E and my metric number is 2019211798. So in this video, I'm going to explain about the lab 2 of milling process, and I'm going to choose the number 11 process. Okay, so based on the diagram here, this is the final product, and the number 11 process I choose this one. Okay, so we can see here this is the number 11 and this is the process of rough mill. So we can see this is the RM, so it means rough mill of the circular one from here. So if we can see from the appendix, we can see that the name of the hole of it is the multi-step hole. So I'm going to write down here, which is rough mill multi-step hole. Okay, next for the cutting tool, I'm going to use all the same, which is the mu and mill. Okay, so for the description of it, I'm going to see based on the appendix. Okay, so for the appendix, we can see that the most suitable one is the 20 as 2010 treaty, and I'm going to choose the LF and LH dimension, which is 110 and 30 for the rough mill multi-step hole. Okay, so I'm going to put the description, which is 20 as 20 then 3T. Okay, so the number of flutes or inserts, I'm going to use the 3 because when 3 it has a bigger size. So when bigger size of the number of inserts, it will make the process much faster because we want to rough mill the step hole. Okay, and then for the size, I'm going to put the 20 because when we use the flutes of 3, the suitable dimension is 20. Okay, and then the LF and LH just now from the appendix is 110 and also 30. Okay, settle part A and for part B, and then we go for the part C. Okay, so the cutter material, as usual, we use the carbide. And then for the cutting speed, that is given, which is 274. And then n millimeter is the same with the size DC dimension. I'm going to put 20. And then machine max, as usual, 6000. And then cutting edge and flux is the same with the number of inserts and flutes, which is 3. And then spindle speed is 4360. And then the chip load is also already given 0.16. And then the feed rate, we are going to calculate using the link that is given. Okay, so we will use this web to calculate. So the unit of measure is in millimeter, and the operation is milling. Material also is the same, aluminium, and cutting material is carbide. And then the cutting speed is 274, and then the end mill diameter, which is 20, and then the machine max is 6000. Cutting edge, we use the 3, and then chip load, we will use 0.16. Okay, and then we are going to calculate. So we will get the feed rate of 2093 millimeter per minute. Okay, so I'm going to put the feed rate of 2093 just now. Okay, so for the estimated time, which is the length of cut over feed. Okay, so based on the diagram, the length of cut is supposed to be the diameter of the circle. So we can see here the hole is 30, which is the diameter of it. So we'll put the 30 millimeter over with the 2093 just now. We get the feed rate, so we will 30 will divide it with the 2093. So we get the 0.014. Okay, settle for the part A, B, and C. Okay, next, the last one for the part D, I'm going to draw the graphic illustration. Okay, so for the diagram, the illustration, I'm going to draw the 3D schematic diagram. So this is the cutting tool, and the main process will be occur here. So this is the overall for the process 11. And that's all for me. Thank you.